I know what you're thinking. Mr. G, you're usually on the other side of the screen. That's because today we're going to continue our discussion of congruence, 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 congruence. Okay, fine, I'll stop. Come on, calm down. Hi, sorry I'm not here. There. Is that freaking you out? Freaking me out too. I kind of like it. Sorry I'm not there with you guys, but we're going to keep going with our discussion of congruent triangles. So I think you already have this in your notes, data 20AB from the text. But what I'd like you to try is check out this as we warm up. You're going to pause me in a second, and I'd like you to, they told us that these two triangles were congruent. I'd like you to tell me which angles are congruent. We're going to try to find out what the value of x is, and then we're going to try to find the measure of angle ABC. This M means the measure, means how big, right? Pause me and write down what angles are congruent. Go. Okay, so because they're in order, right, A and D should be congruent, so these two should be congruent, and B and B should be congruent. That makes sense, and also C and C should be congruent. And that makes sense too because this is a straight line, and so that's 180 degrees, and this little red box means 90 degrees. So if the 180 broken up into two parts means this will be 90 and this will also be 90. Cool? So those are the congruent pieces. Ching! They said find x. Well, x is this angle right in here. So I know that this angle should be equal to 2x minus 16. So we can say 2x minus 16 should be equal to 90. And we'll be to add 16 to both sides. Sorry, I'm writing with my finger. So add 16 to both sides, so 106. And then divide by 2. So 53, that's my guess. Alright, let's try that out. So x, 53, ching! Alright, and now we also want to know the measure of ABC. The measure of ABC. So ABC is this angle. Okay, how are we going to do that? Well, if we know this is 53, and we know this is 49, all of the angles should add up to 180 in the triangle sum theorem. And so we can say 49.3 plus our 53 plus our angle B, let's just call it B for now, those should add up to 180. And we can subtract and solve for B. Use your calculator, use your brain, doesn't matter to me. Bing! 40.7, great. Moving on. We'll address some questions next time. Last time we were here, we looked at some congruent figure just arguments about, like, if we have two sides. Before we said two sides and an angle, and we figured out that we could say that, or if we had all the sides, we could say that the two triangles were congruent, like no questions about it. We tried to build a different triangle, and it didn't work. So I'm going to try this. I've got two angles that are the same. These two are the same, like but these two aren't the same. If you, like, all four of them aren't the same. I made this one a little bit bigger on purpose, right? So they're not the same size. And I'm going to build a triangle out of one of these sets, right? These are the same lengths. So I'm going to build this angle. I want to do this in a really specific way, angle, side, right? So I've got two angles, and I want to make this, like, this side has to be like a certain, like, this is the length that I have to use. So if I put this together, that looks like it would just touch, right? And so I'm going to kind of weld them together now. So this is my new length, and we're going to make this length, right? And so the angles that we're sort of forced into. I'm going to kind of, let's do this again. The angles that we're forced into are this angle and this angle, right? When we've stuck that together. So I'm going to try to group all of these, and let's see. All right, so there's my triangle. Yeah, beauty. Let's see if we can make a different one out of this, right? And so I'm going to mess with this one, move it around a little bit, and move this one. I don't know. Let's maybe move it around. Try it out, and we can mess with this more when I get back. But let's see. I don't know. We can see if we can make a different. Let's see. This one I put on the small side, so maybe we'll do this. Angle, side, right? Oh, this one I put on the small. This is the blue is attached to the small angle. So if I know that I have to put this on. I know the side is attached to one of the specific angles, right? So I'm putting this on the small angle again, and if we kind of crunch it in there, that's the triangle that I think we're going to build, and we'll kind of weld this side together. Let's do it in black. We'll weld this triangle together like that and that. And if we mess with it, if we look at it, really, like, that's the same triangle as this one. And regardless of how you spin these around, you always get the same triangle, provided that we've put the side that we know with the same angle. So in this case, I put this side with the small angle. It doesn't really matter, I just have to do that on this side as well. I put the side with the small angle, right? This side's with the small angle. And so if we have that same setup, we can say that these triangles are congruent. So this is what I'd like you to write down. Pause me and put this in there. You can say two triangles are congruent. Should probably have written that in there. Triangles can be called congruent. Congruent if two angles and a corresponding side are equal. So here's our corresponding side. Right, there's our side. And this blue side is attached to the black dot angle. Blue side is attached to the black dot angle. Right? We know that's, so we can say that those two are equivalent, right? And now you might be wondering, like, what happens if we have not that green angle, but if we have this angle? If we have, and we know that these are equal. Well, if we know these are equal, right, we can say that this and this are equal because all of them should add up to 180. So if green plus red minus 180 equals this x, then the same will happen here. And so once you know two angles, you know all the angles. And so really we just need to know two of the angles and the side in common, the corresponding side. Cool. So another property is this. This is called right angle hypotenuse side. And so if we know that we've got two triangles, right? These are both right triangles. And if you, let's get rid of this big one. If you take two triangles and you know that they have a right angle in them, right? That means they're right triangles. That's this part. And we know that the hypotenuses are the same length. So that and that. That's the H. That's the H. And we know a side. That's that part. And then here's the side. And we know any of the other sides. So if we know this and this are equivalent, or we know that this and this are equivalent, doesn't really matter. we can say that the whole thing is congruent. And why is that? Well, if it's a right triangle, you can use Pythagorean Theorem, and if I know that I have this hypotenuse and this hypotenuse are the same, and this side are the same, we can use Pythagorean Theorem, and we'll always find this would be like 5 and 4. You'd always find that this is 3. And then this would be 5 and 4, and you'd find that this is 3. So essentially, this is saying side, side, side. But a shortcut, we can call it RHS, right triangle, hypotenuse, side. And this is the description for it. I'm going to steal this. We can say triangles can be called congruent if, for right-angled triangles, the hypotenuse and one pair of sides are equal. Write that down and pause me. All right, so we've tried out right hypotenuse side, and we said that's a theorem to say that two triangles are congruent. We've shown side, side, side shows they're congruent. We've shown side, angle, side shows that they're congruent, and we've showed angle, side, angle, and by default, or angle, angle, side, and by default, angle, side, angle. Those are basically the same thing. So there's a theorem in here that you all probably wanted to know about that kind of fits this pattern: side, angle, side, angle, side, angle, angle, side, angle. And we should address that now. And that's, yes, you guessed it, we want to know if angle, side, side works. So does angle, side, side work? I don't know if angle, side, side works. I don't know if angle, side, side works. So let's see. An angle, side, side would work if I had an angle that was equivalent and two sides, right? And I want to see if this will function well. So I'm going to take this, and this has to be angle, side, side in that order. If we did it this way, if we put this here, we'd have side, angle, side, and we know that one works. So I'm going to put one of these, like, I don't know, here, right? Right there. Maybe like that. Right? Angle, side, side. This is the same angle. This is the same side. This is the same length. Right? Like that. And so if I'm going to, you could put a nice third side in here, and I've got a triangle. Right? Not a big deal. I've got my triangle. Let's move it over here. Oh. I could take the same side. I haven't changed anything, but you could flip it this way. And if you weasel it around here carefully, this could come way out there. I haven't changed anything. I haven't changed the angle. I'm just changing the orientation of this final side. And I've got two drastically different triangles. Even though I started with an angle, the side, and another side, this is the same angle, the same side, and another side. I can't say using the angle, side, side theorem. It's not a theorem. It doesn't work because I can draw two different triangles using the same pieces if you're saying angle and a side and a side. So that one doesn't work, which is really too bad. Just so I knew you all were wondering. All right. So one and only one triangle. This is like the summary. Maybe you want to put this down. One summary. One and only one triangle means the triangles are congruent if there are three sides are equal. That's side, side, side. Right? This is side, side, side. Two sides and an included angle between them, which is side, angle, side. Notice the orientation, right? Two angles and a side, so that's angle, angle, side. And then therefore, by definition, since you know two of the angles, you know the third angle. So it would be also angle, side, angle. That one also works. Those are basically the same thing. or if you know it's a right triangle and the hypotenuse and a side are corresponding, RHS, right-handed side. Cool. So those show congruence. All right, what I'd like you to do is finish up this page. I think there's like front and back. There's two sheets of it. Congruence of figures and triangles. Finish that up using those theorems, and I will see you later. Bye.